Hey everyone, and welcome. Today, we're going to pull back the curtain on how a professional, really secure website gets built in the cloud. We'll be using a real-world blueprint from Amazon Web Services to demystify the whole process, step by step. So let's dive right in. Have you ever really stopped to think about it? Not the code, but the actual secure home that a website lives in. The thing that makes it available to millions, keeps it online 24/7, and keeps all its data safe. It can seem super complex, right? Well, it really doesn't have to be. So, to make this easy, we're going to use a simple metaphor. I want you to forget about servers and networks for a minute. Instead, think of us as architects. We are constructing a brand new, state-of-the-art digital headquarters from the ground up. Now, any great building, it starts with a solid foundation on its own private piece of land. And in the cloud, that is exactly where we're going to start. We need to stake our claim and secure our own private plot in this vast digital city that is AWS. This right here, this is our property line. It's called a virtual private cloud, or VPC for short. It's our own logically isolated section of the cloud. You can think of it like a tall fence around our entire digital headquarters. Nothing gets in or out unless we say so. It gives us total control. Okay, so we've got our land fenced off. Now what? Well, we need a floor plan. And that's where subnets come in. We're basically drawing out the different rooms inside our building, and we're designating specific areas for specific jobs. It's how we start to organize our whole space. And this is where it gets really interesting. We divide our floor plan into two main areas. On one side, we have a public subnet. This is our building's lobby, right? It's designed to welcome visitors from the internet. But on the other side, we have a private subnet. This is our secure back office, completely cut off from the outside world. It's perfect for the really sensitive stuff, like databases or internal tools. This separation is absolutely fundamental to good secure design. Of course, every headquarters needs doors. The internet gateway is the big, grand front entrance to our lobby, letting the public traffic come and go. The NAT gateway, though, that's a different beast entirely. It's a special door for the back office. Think of it like a high-security delivery bay that only opens from the inside. This lets our private systems go out to the internet to get, say, software updates without ever letting the internet get in. It's a one-way street, and that's the key. All right, so our headquarters is built, but what if something happens to the city block it's on, like a power outage? Having a single point of failure is risky. So now we're going to make our architecture resilient. We're going to make it tough. And the solution for that is something called an availability zone, or AZ. Just think of an AZ as a completely separate data center, maybe across town, with its own power, its own cooling, its own networking. To make our business resilient, we're literally going to build an identical copy of our headquarters in a second AZ. That way, if one of them has a problem, our business just keeps running from the other one, no sweat. You see, our initial blueprint was built in just one availability zone. It works, sure, but it's not what you'd call robust. One little issue over there and our whole website goes dark. Not good. So we expand to two. We add a whole second set of subnets, a public and a private one, in a completely new AZ. And just by doing that, we've achieved high availability. Our website now has a backup location ready to go, and it can survive an entire data center failure. Now, to make sure everything talks to each other, we have to update our route tables. Think of these like the building's directory you see in the lobby, or maybe like the internal signage. They give the network traffic the critical directions on exactly how to find those new rooms in our second location. It just makes sure everything flows smoothly. Okay, the structure is built and it is resilient. But before we move in our expensive equipment, like our web server, we need to hire security. We have to define exactly who is allowed in and where they're allowed to go. And that is the job of a security group. It acts like a virtual firewall. Or, to stick with our metaphor, it's like a dedicated security guard standing at the door of each and every server. And this guard has a very, very specific list of rules. If you're not on the list, you are not getting in. Simple as that. Now for our web server's security guard, the rule is incredibly simple. You can see it right here. We allow HTTP traffic, which is just standard web browser requests, from anywhere on the internet, and that's it. This one single rule is what lets visitors actually see our web page. Everything else, denied by default. The foundation is laid, the building is resilient, and security is in place. It's finally time for the main event. It's time to move in the equipment that's actually going to run our website. Let's launch our web server. So, launching involves a few key decisions. First, we pick an operating system and a small, efficient server size. Next, and this is important, we place it in our public subnet, our lobby, so that visitors can actually get to it. And finally, we assign our web security group to be its dedicated guard. Now, here's a really cool part. To automate the setup, we use this little script called user data. I want you to think of it like a self-assembly instruction manual that we hand to the server the second it launches. The moment it powers on, this script automatically runs, installs the web server software, and starts it up. No one has to lift a finger. With the server running and all the software installed, it gets a public IP address. All we have to do is copy that address, paste it into any web browser, hit enter, and there it is. Our website is officially live on the internet for the whole world to see. And there you have it. We did it. We've built our digital headquarters. So let's just step back for a second and admire the complete blueprint of what we've just put together, piece by piece. You see, the entire thing lives inside our secure VPC. That's our property line. And inside we have our rooms, our subnets, built across two distinct availability zones to make sure it's always online. All the traffic is controlled by two very important doors: the Internet Gateway, which allows public access into the lobby, and the NAT Gateway, which provides that secure one-way door out for our private systems. And finally, the centerpiece. Our web server sits right where it belongs, in the public lobby, with its own dedicated security guards standing at the door, making sure only legitimate web traffic can get through. What you're looking at is a complete, secure, and resilient web architecture. So, we've built the headquarters, and we've launched our website in the lobby, but did you notice? That secure, private back office is still empty. This professional foundation is ready for so much more. So the real question isn't just what we built today, it's what will you build next? A database for your app? A fleet of internal microservices? This blueprint is now yours.